Hi, welcome back to my channel. We already discussed the types of piles according to materials of construction, cross section and shape. Today we are going to learn about the other three types, which are mode of load transfer, method of forming and method of installation. We know as per mode of load transfer, there are end bearing piles, friction piles and tension piles. Let us learn each one in detail. End bearing piles. End bearing piles transmit the loads through their bottom tips. Such piles act as columns and transmit the load through a weak material to a firm stratum below. If bedrock is located within a reasonable depth, piles can be extended to the rock. The ultimate capacity of the pile depends upon the bearing capacity of the underlying material. If instead of a bedrock, a fairly compact and hard stratum of soil exists at a reasonable depth, piles can be extended a few meters into the hard stratum. Thus, piles are also known as point-bearing piles. The ultimate load carried by the pile is equal to the load carried by the point or bottom end. Friction piles. Friction piles do not reach the hard stratum. These piles transfer the loads through skin friction between the embedded surface of the pile and the surrounding soil. Friction piles are used when a hard stratum does not exist at a reasonable depth. The ultimate load carried by the pile is equal to the load transferred by the friction. Friction piles are known as floating piles as these do not reach the hard stratum. Tension piles. Piles are also used to resist uplift loads. Structures such as tall towers, silos, chimneys, offshore platforms and the dry docks are usually provided with pile foundations to resist the large uplift forces, hydrostatic pressures and overturning moments. Piles used for this purpose are called tension piles or uplift piles or anchor piles. The uplift capacity of pile is calculated in a manner somewhat similar to the determination of the pile capacity under compressive load. We know next one is as per the method of installation. They are driven, bored, vibrated and jetted. Driven piles. Driven piles may be of timber, steel or concrete. When the piles are of concrete, they are to be precast. They may be driven either vertically or at an angle to the vertical. Generally, they are driven into the ground using an impact hammer or a vibratory hammer. Driven piles generally cause high displacements. The larger the diameter, the larger the displacements. Concrete, timber or closed-end pipe piles that are driven into the ground are often medium to high displacement piles depending on the diameter. Types of driven piles are steel piles, precast concrete piles, timber piles and composite piles. Bored piles. Concrete bored piles are commonly used due to their high strength and moderate cost. In bored cast in situ piles, boring is done either by augering or by percussion drilling. After boring is completed, the bore is concreted with or without reinforcement. Vibrated piles. Vibratory pile driving is a method in which the pile is vibrated into the soil rather than being hammered in. The type and classification of the sound that is generated with vibratory versus impact pile driving is different. The sound generated from vibratory pile driving is classified as more non-impulsive, continuous sound as opposed to the impulsive and sharp sounds produced from the impact pile driving. These are displacement piles. Jetted piles. Jetting is a technique that is sometimes used in pile driving when the pile needs to penetrate a thin layer of hard soil, such as sand and gravel, overlying a layer of soft soil. In this technique, water is discharged at the pile point by means of a pipe 50 to 75 mm in diameter to wash and loosen the sand and gravel. Piles also may be advanced by partial augering with the power augers used to pre-drill holes part of the way. As per the method of forming, we have precast, pre-stressed and cast in situ. We already learned these type of piles under the concrete. Precast piles can be prepared by using ordinary reinforcement and they can be square or octagonal in cross section. Reinforcement is provided to enable the pile to resist the bending moment developed during pickup and transportation. The vertical load and the bending moment caused by a lateral load. The piles are cast to desired lengths and cured before being transported to the work sites. Pre-stressed concrete piles. Precast piles can also be pre-stressed by the use of high-strength steel pre-stressing cables. During casting of the piles, the cables are pre-tensioned and concrete is poured around them. After curing, the cables are cut, producing a compressive force on the pile section. Next is cast in situ. A cast in situ pile is constructed by making a hole in the ground and then filling it with concrete. The hole may be formed by drilling as in caissons, that is bored cast in situ, but usually it is formed by driving a metallic shell or a casing into the ground. It is driven cast in situ. If during the process of concreting the hole, the casing is left in position, then it is termed as cased pile. The casing may be gradually withdrawn. In that case, it is termed as uncased pile. Uncased piles can be uniform diameter or may be provided with an enlarged end or a pedestal. Displacement of soil. As per the displacement of soil, we can classify it as displacement piles and non-displacement piles. If during the installation of the pile, a large volume of soil is displaced laterally and upwards, such a pile is called a displacement pile. In a loose sand, such a pile densifies the sand up to a distance of about 3.5 times the diameter of the pile measured from the center of the pile. Driven and cast in place, driven, precast or pre-stressed concrete piles, timber piles, etc. are examples of large displacement piles, while there are some piles like the rolled steel section piles, screw piles, open-ended hollow section piles, etc. which are classified as small displacement piles because on account of their small cross-section they produce small displacement of soil. Small displacement piles are preferred when ground displacements and disturbances are to be minimized. Non-displacement piles. Non-displacement piles are those piles whose installation does not lead to any displacement of soil at all. A void is formed in the soil by boring or excavation and is then filled with the concrete. The sides of the void can be unsupported or supported either permanently by casing or temporarily by casing or drilling mud. Bored, cast in situ and bored precast piles are examples of non-displacement piles. Let us see a video regarding installation of piles. This is the website of railwaysystem.net. Under the construction tab, we can see here sheet pile wall construction. If we open this, here all the details are given and a video is there showing how sheet wall is installing. This is driven pile. Another one is secant pile wall construction. Here we can see the video. Casing is removed. And that's it. I hope you have enjoyed this lesson. Thank you for watching, and don't forget to give this video a thumbs up and click subscribe if you are new to my channel. See you.